In this video, we're going to learn how to calculate the resultant force and resultant moment about a point using our sum of forces and sum of moment equations. So in this example here, we have this platform like so, and then we have these two forces acting on the platform at this point right here. And so we're asked to find the resultant force and the resultant couple moment at point O. And we know that the resultant force is equal to the sum of forces, and then we also know that the resultant moment about a point is equal to the sum of r cross f at that point, or the sum of the cross product of the perpendicular distance times the force. So let's start with the sum of forces here in our calculation. Okay, so we'll do sum of forces first. Sum of forces. Okay, so what we're doing here in this segment is we're going to find the resultant force. That's the first step. We're going to find the resultant force first, and then we're going to find the resultant couple moment. So in this example, we have two forces here. Okay, this 20 Newton force here, and this 50 Newton force here. And what we're asked to find in the resultant force, what the resultant force means is that if we were to take away these two forces and replace it with just one force called the resultant force, that force would have the exact same effect on the platform as these two forces here. So let's go ahead and do that. And as we know, as we stated earlier, that the resultant force is equal to the sum of forces. So to do this, what we're going to do is we're going to get the resultant force in the x direction, and then we're going to get the resultant force in the y direction by doing sum of forces. So we know that the resultant force, which we'll call FR, F sub r, x in the x direction, is equal to the sum of forces in the x direction. And before we get to any calculation, we're always going to define which way is positive. And so we're going to define the positive x-axis as positive just for convenience. Okay. You can make any direction positive as long as you stay consistent in your calculations. So let's go ahead and let's solve the sum of forces. So we'll start with the 50 Newton force here. Okay, so as you can see here, it's pointing in the positive x direction, so it's going to have a positive sign. And to get the x component of it, what we're simply going to do is we're just going to take the ratio of this vector, okay, of the force, or sorry, of the x component of the force, and the hypotenuse component of the force, and then multiply it by the total force, the magnitude of the force. So what we're going to get is 15 newtons, which comes from here, times, okay, the x component of the force, okay, which is 4, divided by the hypotenuse component of the force, which is 5. And what we're doing here is we're trying to get the two hypotenuse components to cancel out. So as you can see here, 15 lies along this hypotenuse component. So we want these two components to cancel out. And so what we're left with is the x component. And then we're going to go minus, okay, because now we're going to focus on this force here. 20 newtons, as you can see, is pointing in the negative x direction. So that's why we have a minus sign here. And to get the horizontal component of this, as you can see here, we have a 30-degree angle. What we're going to do is we're going to find the opposite component because the angle is here. So the x component is in the opposite direction, not the adjacent, the opposite. And we know from trigonometry that the opposite component is sine of the angle. So we're going to get 20 sine 30 newtons. and then we put that into our calculator, we get 2 newtons. So the resultant force in the x direction is 2 newtons. Okay, so how about the y direction then? Okay, so we know that the sum of forces, or the resultant force in the y direction, is equal to the sum of forces in the y direction. And like always, we're going to define which way is positive, and we're going to define up as positive, and then we're going to go and put in our calculation. So as you can see here, both forces point upward, so they're both going to be positive. So we're going to start with the 15 Newton force here. So we're going to go 15 newtons times this ratio here, 3, okay, because we're after the vertical component. So we're going to multiply 15 by 3 divided by 5. And then we're going to plus 20 cos 30, okay, because we're after the adjacent side now, okay. We're after the adjacent component, that'll give us the vertical component. So we're going to go 20 cos 30 newtons. And when we put that into our calculator, we get 26.32 newtons. Now, there's two ways of writing the resultant force. We can write it in Cartesian vector form, and we can also write it in terms of its magnitude and its angle. So in Cartesian vector form, it's actually the easier way of writing it. So essentially what we do is we just write the resultant force, Fr, is equal to the different components. So it has an x component, so which is 2 newtons. So we'll write 2, and then we'll put an I, okay, which represents the x coordinate, plus the y coordinate, 26.32 J newtons, okay, and this would be sufficient. Now if you're asked to write it in terms of its magnitude and its angle, then that's easy as well. All you do is you just do the Pythagorean theorem on this. So this is Cartesian vector right here. Vector form. And then we can also write its magnitude, or we can write this force in terms of its magnitude. So Fr is equal to the square root of 2 squared plus 26.32 squared. 2 squared plus 26.32 squared. Like so, and this will be in newtons, of course. And what we get is 26.4 newtons. So 26.4 newtons. So that is the magnitude of the resultant force. And then of course what we have to do too is we have to determine what the angle is. So we know that the x direction is 2, it's positive 2, okay, and we know that the y direction is positive 26.32. Okay, and then this right here is going to equal this right here, which is 26.4. So what we're after is the angle. You can use any angle you want, but for convenience, we're going to use this one. So that means if we're using this as theta, what that means is when we take the tan, okay, we have to use the, as you know from trigonometry, it's going to be the opposite, which is 26.32 over the adjacent, which is 2. And we're just going to indicate that it's this angle here. So I'll show you how to do that. So when we do theta, theta is equal to of 26.39 over 2, we get 85.7 degrees. Okay, and when we write our angle, we're also going to indicate which angle it is. So we're going to write it like this. Okay. Now, of course, you can do it in terms of this angle here too, in which case you would just take the arctangent of 2 over 26.39, because now this would become the adjacent and this would become the opposite. So you'd go 2 over 26.39, and then when you indicate the angle, you would just indicate it like this. So you would write your angle like that. Okay. Okay, so that is the sum of forces. How about the sum of moments? So we'll just scroll down here and create a little bit more space. And by the way, I'm just going to circle this or box this up as the answer to the first part of the question. Now we're asked to find the sum of moments. So let's do that now. Okay, so sum of moments, or the resultant moment. Okay, so how do we go about this calculation? Okay, so again, what we're doing is we're considering all components of the different forces here to add up our sum of moments. So as we know from our equation that the resultant moment about the origin, okay, about point O, which is the point in question here, is equal to the sum of moments about that point. So what we're going to do first and foremost is we're going to define which direction is positive. We're going to define, you can define any side, you can define any direction. You can do clockwise, or you can do counterclockwise. For this question, I'm going to do counterclockwise. Okay, so counterclockwise is positive for this direction here. And then we can go ahead and start doing our calculations. So first off, let us consider this force here, the 20 Newton force. And in both forces, what we're going to be doing is we're going to be considering both components. We're going to consider the y component, and then we're going to consider the x component. Well, what do we know? So we know that the moment is the force times its perpendicular distance. So we know that the horizontal component of the force, okay, is 20 sine 30. Okay, so this component of the force here. So that means if this force was pulling on the bar this way. Now, what else do we know about this this force here in terms of how to calculate the moment? Well, we also know its perpendicular distance, right? Which is this right here. So if this is the force here, its perpendicular distance would be this. Now, what is this component here? What is this distance? Well, we aren't told explicitly, but we know that this distance here is 6 meters and that the angle is 40 degrees. So with some trigonometry, we can figure out what this distance is, and it's going to be 6 times sine 40. So write that 6 sine 40. And we know that this will cause a counterclockwise tendency, counterclockwise rotating tendency. So that means it's going to be positive. So we're not going to put a minus sign in front. We're just going to leave it here. Okay, so what about the positive component of the force? Okay, this right here. All right, so if this 20 Newton force was pulling like this, okay, what's its horizontal distance? Well, its perpendicular distance. It's all this right here. So what we're going to do is we're going to multiply this component here times this distance here to get the next component of our resultant moment. Okay, and we know that if the force is pulling up like this, it'll cause a counterclockwise rotating tendency. So that means that this component of the force will also be positive. So this component of the moment will also be positive. So we're going to go force times perpendicular distance. The vertical component of this force is 20 cos 30. And then we're going to multiply this by this entire distance, which is going to be 2 meters plus 1.5 meters or what I should do is this, just for consistency. So plus this distance here, which will be 6 cos 40 plus 6 cos 6 cos 40 plus this distance here, okay, the rest of the way, which is 1.5 meters. All right, so now we're done with this force. Let's move on to this one here. So let us start with the let's start with the horizontal component of this force here. So we know that the horizontal component is 4, so it's going to be 15 times 4 over 5, okay, which is going to pull it this way, and we're also going to multiply it by its perpendicular distance, which is all this here. And now we know that if it pulls this way, it's going to have a clockwise rotating tendency. So that means that the component of the moment is going to be negative. Okay, so negative, and then the horizontal component of this force right here is going to be 15 times 4 over 5, as we did in the last question. 15 times 4 over 5 newtons. Okay, I should have put the units in here. I'll put it here, newtons, and this is going to be meters, newtons, and then this is all going to be meters. Okay, newtons times 6 times sine 40. Okay, because this distance here is going to be 6 times sine 40, as we did in this calculation. 6 sine 40. And last but not least, we're going to consider the vertical component of this force. Okay, so this force right here, okay, pulls in this direction like that, and then we're also going to multiply it by its horizontal or its perpendicular distance here. And we know that the vertical component of this force is 15. Okay, we're going to put a plus sign because since it pulls up, it makes a counterclockwise rotating tendency, so it's going to be positive. So we're going to go 15 times 3 over 4 newtons, that's the vertical component, times this entire distance here, which is the same as this. Okay, so 2 plus 6 cos 40 plus 1.5 meters. So when you punch all that into our calculator, we get this. We get 205.4 Newton meters. Okay, or we can just simply write 205 Newton meters counterclockwise. Okay, since it's positive, it's going to be counterclockwise. So we just write counterclockwise. Okay, and that would be our resultant moment right here.